let's see. In this chapter, you've talked about multiplying and reducing fractions. And then we just start talking about adding and subtracting fractions. What's left? Well, what's left is division, right? Dividing fractions. It turns out, we'll do that in the next problem set, but dividing fractions is easy. It's all on the wrist. But it's nowhere near as hard as adding and subtracting because you don't need to find the LCD. Anyway, we'll get to that. But anyway, so let's review this concept of additive inverse. Remember what the additive inverse or opposite of a number is? The additive inverse, there's two ways to think of it. You could either think of it as asking what do you add to this number to get 0? Or the other way to think of it is what do you get when you reflect that number across 0? So if it's 3/4, the additive inverse would be negative 3/4, right? Negative 3/4. Okay. Or like I said, or you could think of it as in terms of an open sentence. The additive inverse is the number that makes this into a true closed sentence, right? All right, so let's talk about something different now. Speaking of open sentences, let's look at this. I'm asking you, what number do you multiply 3/4 by to get 1? That's a totally different question than what do you add to get 0. But think about it. Here's a hint. It's going to be a fraction. And you know from what you learned earlier that things have to cancel. When you multiply, the only way you can get rid of things when you multiply is by canceling them. So you're trying to make this whole thing into a 1. So how would you cancel that 4, for example? Wouldn't you have to have a 4 on the top? And how would you cancel that 3? Well, you'd have to have a 3 on the bottom. Now when you multiply, the 4's would cancel, they'd form a 1, and so would the 3's. So that's your answer, 4/3. 4/3. Anyway, that introduces the concept of what are called multiplicative inverses, or better known as reciprocals. We say 3/4 and 4/3 are reciprocals because when you multiply them together, you get 1. So you think, well, so what? Well, it turns out that's a very important idea when we get to dividing fractions. So it's coming. But two numbers are reciprocals if their product is 1. So what would be the reciprocal of 5/7, for example? What do you multiply 5/7 by to get 1? It turns out the reciprocal of a number, you just flip it over. See, it's all on the wrist. See? All on the wrist. The reciprocal of 5/7 is 7/5. Why does it work that way? Because when you flip it over and then you multiply it, everything cancels. That's the idea. How about this? What's the reciprocal? In other words, what do you multiply this by to get 1? As before, it might be nice to think of this as a improper fraction. So what would you multiply that by to get 1? What do you get when you flip it over? Well, it'd be 3/7, which we usually put the negative on the top, though. So negative 3/7 is the reciprocal of negative 7/3. All right? How about this? What's the reciprocal of 5? Of course, the trick on that one is think of it as 5/1. So then the reciprocal becomes 1/5, right? What's the reciprocal of a/b? The reciprocal of a fraction is b/a. That's right. All right. Let's do some more here. Tell you what. Okay, let's do some more. Why don't you try some? I want you to tell me for each of these numbers, see if you can figure out the multiplicative inverse, which is just a fancy way of saying the reciprocal. Find the reciprocal, and also find the additive inverse, which is just a fancy way of saying the opposite. Okay, go ahead. Hit the pause button and we'll go over these in just a minute. Okay, for the first one, you might think about this negative on the top. The reciprocal of 9/5 is negative 5/9. Checked. When you multiply it back through, do you get 1? The additive inverse, that goes way back to chapter 1. What do you add to this to get 0? It would be positive 9/5, right? When you change this to improper, what do you get? 5/3. So the reciprocal would be 3/5. And what is the additive inverse of 5/3? It would be negative 5/3. Good. X over 2w. Well, the multiplicative inverse, remember, you got to get 1, so you'd flip this over and you get 2w over x. Go ahead. When you multiply by, you get 1. And the additive inverse would be negative x over 2w. That's weird. What is the multiplicative inverse of negative 1? What do you multiply negative 1 by to get 1? And the answer is negative 1, right? What's the additive inverse of negative 1? What do you add to negative 1 to get 0? The answer is 1. Now this one is the tricky one. How come 0 doesn't have a reciprocal or a multiplicative inverse? You know why? Because 1 over 0 is undefined, right? Remember, 0 is 0 over 1, so 1 over 0 will be undefined. 0 does not have a reciprocal. Every other number does. 0 is kind of weird because it doesn't have a reciprocal, but it does have an opposite. In fact, it's its own opposite, right? Negative 0 equals 0. Okay, so this idea of reciprocal is going to be a very important concept in the next section. But before we do that, let's do some of these problems. I know students have trouble with these sometimes. This is just more practice with thinking about the concept of reciprocals. What do you multiply negative 1/5 by to get 1? Well, isn't that just the reciprocal? That's the definition of reciprocal, so it'd just be negative 5 over 1, right? This one is a little harder. What do you multiply negative 1/2 by to get 1? Well, negative 1/2 is the same thing as negative 3/2, right? So what do you multiply negative 3/2 by to get 1? It would be the reciprocal, which would be negative 2 over 3. Some of these get a little harder. This is one that's, I think, a little challenging. It's a little different. We're not trying to get 1, we're trying to get 2, but here's my advice. You want everything to cancel, but you want to have a 2 left, right? So if you have a 3 on the top, aren't you going to have a 3 on the bottom, right? So that would cancel the 3's. Now I want to have a 2 left on the top. So if you have a 4 on the bottom, you'd have to have a 4 on the top, right? What do you have so far? You'd have 1, wouldn't you? Because the 4's would cancel and the 3's would cancel, so let's put a 2 in there also. See, I put a 4 to cancel with this 4, a 3 to cancel with this 3, and I have to have a 2 left because I want to have a 2 left on the top. So the answer would be 8 over 3, or you could just leave it like that too. So just play around and so that things cancel. This one looks hard, but it's not that bad. This is actually easy, I think. What do you multiply negative 3/11ths by to get 0? I'm multiplying, folks. What do you multiply a number by to get 0? Think about it. That's right. Good. 0. All right. Well, let me give you a couple to try. Go ahead, hit the pause button, try these, and we'll go over them in just a minute. Okay, the first one, remember, it's a fraction. So this one actually isn't quite as bad as the one we just did earlier. I want to have an x left. So all I want to do is cancel this y. I don't want to cancel the x. I want to have it still there. So if there's a y on the bottom, let's put a y on the top. I'll just put y over 1, or y. See, when you multiply this back through, don't the y's cancel? You have x left. All right, how about this one? What do you add? This is an add now. This is not a multiply. What do you add to negative 3/11ths to get 0? Why, that's just the definition of opposite, right? That's the opposite of negative 3/11ths, which is 3/11ths. Alrighty, we'll see you next time. Bye-bye.